Today, we focus on the cost associated with maintaining inventory for a single product when demand is constant. For example, when we know that annual demand is some amount D, and buyers arrive at a fixed rate. Consider the level of inventory for such a product, and the evolution of this inventory level over time. Starting at any arbitrary inventory level at time 0, we know that this level will decrease at a fixed rate due to demand, and this rate is equal to the fixed arrival rate of buyers. If we assume that we can time deliveries from our supplier, then we can ensure that a new order arrives just as the inventory level reaches 0. This replenishes our inventory and sends the level back to our order size, Q. This cycle can then repeat for the rest of the year. Under this scenario, our average inventory level will be the order size Q divided by 2. Given this structure, we would like to minimize the cost associated with maintaining this system. We will focus on 3 distinct types of cost. First, we have the purchase price of the items that our supplier delivers to us. For now, we assume that we pay a fixed price per unit, and we label this amount P. Thus, our annual procurement cost is simply P times D. Second, we consider the cost of holding this inventory until we give it to our customers. We typically write this holding cost as H. This cost has at least 3 components. There is the opportunity cost associated with the capital that is tied up in inventory. We also have direct cost, such as wages for personnel involved in handling the inventory, as well as the reduction in value over time due to spoilage, theft, or obsolescence. Finally, we must consider the indirect cost, such as a share of warehouse rent, insurance, and supervision. We must also acknowledge the cost associated with placing orders. These are sometimes called setup cost, which I write here as S. Again, these costs may be direct, such as delivery fees, cost to unload a truck, or set up a machine. They can also be indirect cost, such as allocated overhead related to staff or information systems that track inventory. With this understanding in hand, we may turn to our larger objective, namely minimizing the sum of these costs. Again, total cost include the purchase price, the holding cost, and the ordering cost. We will treat these as functions of order size Q. Note that when viewed in this way, the purchase price is actually independent of Q. The holding cost can be written as the average inventory level times the cost to hold 1 unit in inventory for a year. This is Q over 2 times H. Also, if annual demand is D, we place orders of size Q, and we pay a price of S each time an order is placed. We get ordering cost of D over Q times S. To find the order size that minimizes this function, we consider the derivative of total cost with respect to Q and set it equal to 0. From here, simple algebra allows us to rearrange terms to yield the final result shown here. This value, that I write as Q star, is known as the economic order quantity, or EOQ.